This next problem, we are considering that same 20 kilogram mass being dragged across the floor, but now we're going to apply a force, a second force to it that is acting into the ground, so downward. So all of these forces still exist because we have an applied force across the floor. We have frictional force opposing the motion. We have the normal force from the floor's interaction, and we have gravity acting down. But now we have, we'll call it Fc, acting down on this object as well. Okay, so our applied force from the other two problems does not change. We're still on that same ground, so 0.3. If our 20 kilogram mass is the same, our Fg stays the same. But now we're going to say that force pushing down into the ground, let's say, is 45 newtons. All right, and once again, we want to solve for acceleration. We're going to set up the net force equations. Still in the x, we just have the applied force, the first applied force, and the frictional force acting in different directions. And we're still saying we have an acceleration equals m times a. This time the net force in the y is the normal force minus that force being applied down here, and minus gravity as well. In the y, since we're still sitting on the ground, that equals 0. Once again, to solve for this, we know Fa, we know the mass, we need to find the force of friction. So it's just our mu Fn. So we need to solve for Fn. So the same way as before, but now, since that Fc is acting down, these are added. And that makes sense because if it's added in this negative direction, we're adding to that interaction. It's getting pushed harder into the ground. Therefore, the ground has to push back more to cause it not to accelerate. So that's what this equation means. The ground has to push back more so you don't fall through the ground, basically. Alright, so our Fn in this case is Fg 192.2 plus 45 newtons. Get 237.2 newtons. So our force of friction here is 0.3 times 237.2 newtons. So now our frictional force gets larger. Now it's 71.16, and that makes sense because since we're pressing it down harder into the ground, there's going to be more frictional force there. Alright, so now we know our Fa, our Ff. We're solving the net force in the x. So I'm going to go back to the original way of just finding the value. Get 48.84 newtons. So this is our unbalanced force that is causing that 20 kilogram mass to accelerate. Solve Newton's second law. So we get 48.84 4 newtons divided by 20 kilograms. We get 2.442 newtons. And so now we get a smaller acceleration because we have a larger frictional force. So our net force is smaller because we have to take the difference, and therefore our acceleration is smaller as well. I put newtons, meters per second squared. Everybody was yelling at their screen there for a second. Meters per second squared.